All right. So today, as promised, we're looking at your data again and trying to solve some problems that you've encountered. But I did get a question about how to organize the final project overall. And I expect that actually a lot of you will be interested in the answer. So I'm going to walk through what your final project organization should look like. And this is actually good advice for any data analysis project that you've got going. So up to you whether we do first or project organization first. Anyone have a preference?
Project first.
All right, bring it on, Carlos. Is that Carlos?
Oh no, sorry, I meant the other way, the other way.
Oh, the other
My bad.
project.
Confused. Yeah.
Project organization. All right, let me share screen. All right, can you see that? So I'm going to start a brand new project, pretending that this is my final project for the class. All right. So I'm going to do it in a new directory, new R project, example final. That's what I'm going to call it. And I'm going to stick it just right on my desktop so it's easier to find. Open. And I am going to create a Git repository with it. Okay. So we got a lot of stuff here. For my final project for this class, let's say I'm doing that bird measurement data that we looked at before. So let's take a look at my directory structure. Oops. CD example final. All right, so I've got the Git in there. I've got my R project, my Git ignore. All right. So first off, a good project directory structure, everything's self-contained. Remember, we want all of our data in here. We want all the analyses and all the outputs so that our file paths are relative. So I'm going to make a new directory called data. I'm going to make one called R for my R scripts. And I'm going to make one called output. Okay. This is just kind of what I do. It's up to you, but this is a pretty nice little workflow using R. Okay. So here I am. I've got a folder for my scripts, folder for my plots and statistical tables, and a folder for my actual data. So I'm going to actually move that data in here. I'm going to copy from desktop, data courses on data. What was it? Bird measurements.csv. I'm going to copy that into data. Okay. So here it's showing me my directory structure. I've got data, and there's bird measurements.csv. Who remembers what we did with this? It's been like a week or so.
Oh, we cleaned this a lot.
That's it.
Right?
We did. We cleaned it. And it was kind of an annoying, complicated cleaning process. Not too horrible, but I don't want to have to do that again. So I took that cleaning script, the one posted on our copy-paste page, and I'm just going to copy that. I'm going to start a new file, new script. I'm going to paste it in and maybe make it a bit prettier. That stuff we didn't actually wind up using. There's our clean data. We stick them back together. Okay, Now, projects can get really big. This one's already 40 lines of code long, and all we did was clean the data. I don't want to have to do this every time that I want to start up and work on this project. What could I do?
You put like 4 hashtags and it collapses everything.
I could do that. So I could say that this is the cleaning, and that collapses all of it into there, but that code's actually still there.
You could make a new
file.
CSV with the cleaned up grid, yeah.
That's what I want to do. Yeah. So I'm gonna run this Control-Alt-B. Oh wait, is it the right? Oh, it is. It's the right project structure. Perfect. So I've got it there. It's full. So I could say write CSV. I could write full. And where should I send it? Here's my project structure.
Your final project folder.
Well, I'm already in there, remember? Because I'm in my new R project. So
Put
this
it in
is my
data?
example final. Yeah, I want to send it right back to data. So I'll send it to data cleaned data.csv. Done. Okay, I'm
Should
going to
we-
save this script.
Should we actually have this right on our desktop, or should it be inside our folders? Our
Yeah, for yours, it'll be in your Git repository.
All right.
You'll just have a new folder in there that's final project.
All right.
Okay, so I'm going to save this script as O1 clean bird data. And I'm actually not going to save it right here in the main directory. I'm going to stick it in R and save it. Okay, so now I've got my script for cleaning, and I've called it O1, and so that's the first thing that's going to pop up. All right, so if I'm in here, I look around, I say, oh, CDR, there's O1 clean bird data. Okay, what's next? I don't need this script anymore unless my data changes. So I'm going to start a new one. And I'm going to say analyze cleaned data. Packages. What packages do I want? Somebody help me.
Of course, tidyverse.
Uh-huh. Yeah, it's probably good for right now. We'll see if we need anything else, like more advanced statistics or something, but let's leave it there. And then the next thing, I'm going to read in the cleaned data. So how do I do that?
Just read CSV and then file you just created.
And where is it?
Data.
It's in data. If I hit tab, there it is. There's the cleaned one. All right, so I'll save that as DF. Okay, so now we've got our clean data, and look how tidy our script is. All that cleaning stuff, we've actually just moved that to a separate file. You don't need to show me all that cleaning in your final report, your markdown report that you generate. I don't need it. It's ugly. It's fine. You can relegate that to another script and just start with your clean data. So let's take a look at it. Family, species, number, name, English name, clutch size, egg mass, mating system, measurement, value, and sex. What type of analysis might I want to do with this?
See the effect of mating system on egg mass, maybe, or clutch size
Okay.
on egg mass.
Yeah, and remember, this is like real data from the wild, and it didn't come with an explainer as to what mating system numbers actually mean, but there they are. Also, you might notice mating system got read in as a double, a numeric. So we're going to have to do maybe a bit more cleaning. Okay. But we can also do that within our analysis. So let's see. Effect of mating system on egg mass. Clutch size, was it? Yeah. Clutch size was lowercase.
I have a question.
Okay, so how do I start?
You could just visualize it with a plot. Just start if you want.
Not that I could, but that I should. Always. Always visualize, remember? Clean, tidy, visualize, then model, then report. So let's do a little plot. ggplot. We'll just call this P1. And we're using our DF, our data frame, and the aesthetics. X equals, what should X be?
I'd say mating system as a factor.
Yeah, factor, mating, how's it spelled? Capital S. Okay.
And then just clutch sizes. Y.
Equals clutch, lowercase size. Do we want to color by anything? Might get ugly. That might be a lot of colors. Let's see what we find with this. Plus, what type of graph?
I would just do a box plot, but
Yeah, I would too. Geom box plot, and then we'll look at our graph there. Okay. See anything?
Y2.
NA. So maybe we get rid of these NAs for mating system. So up here, instead of sending DF to our ggplot, maybe we do DF and filter out mating system, anything that's not NA. So we can say not is NA. And then send that to ggplot. So we don't need to tell it what we're using. Okay, so we got rid of the NA. Yeah, so 2 does have all these outliers compared to the rest. Okay, so great, we made our visualization. And yeah, it's ugly, so maybe we want to say theme minimal. That looks a bit nicer. Change the labels. X equals mating system. Nice 2 words there. Y equals clutch size. Okay, I'm happy with that plot. I know it sucks, but we're just looking at the workflow. What do I do with the plot outside of R? I gotta be able to throw it into a report, save it to a file. So I'm just gonna go ahead and toss in a GG save. And where do I want to put this? What options do I have here?
Oh, maybe. What is your output?
Yeah, let's do it there. Output fig1.png. Maybe I'll even give it a descriptive name. Box plot of mating system on clutch size. Done. What's the next step in our workflow? Visualized.
Well, I just have an idea though. Why don't we view how many observations each of these mating types actually has? That might explain why one has more outliers.
Okay. So we're not done. We visualized one thing, but there's more we want to see. So how would we do that? We could use table, df, mating system. Ooh.
And number 2 has a lot more, and that's why it has more outliers.
Tons, yeah. So let's save this to a file also. I'm going to do that with sync. So I'm going to send that to output and call it table1 and mating systems.txt. Remember, sync works just like the old PNG, where if I hit Control Enter on there, anything that I run now, instead of getting stuck just to my console here, will go to that file until I say sync null. Okay, so now let's take a look at our output. See, output. There, we've got table 1. We can cat that just to see. Great. It's not super descriptive. So maybe I'll add a little bit of text. Number of observations for each mating system. And then give it a little new line character. So let's try that. Run that again. Okay, so now it tells us what we're looking at. Neat. Okay, so we've done some visualizations. The next step in our loop is
The model, right?
yeah.
Yeah, we visualize, and you can make models, compare
All
some
right,
models.
so walk me through this model. Dalton, I'm picking on you because you're talking.
Great. Should have never unmuted myself. So,
Yep.
all right. Model. We are looking at what mating system versus clutch size. And so mating system is our dependent variable, right? So everything's going to go by, or you're going to put the is it called the tilde or whatever, after mating system for creating the model, right? Oh, flip-flopped.
Yeah, because remember the tilde means as a function of, and so the dependent variable goes on the left-hand side.
Yeah, that's what I meant.
Oh, okay, yeah.
Yeah, so that's
Okay,
good.
so
That's
do
what's
we
gonna
want to
go first.
use AOV or GLM?
So GLM's for linear and AOV's for non-linear, right?
Yeah, in this case.
Um,
It can be done with, it's a special case of GLM.
I'm not
Since
sure.
we've got one predictor, we can use
the
either.
linear.
It's actually going to give us the exact same results. But the benefit of AOV is that we can also do a Tukey test afterwards. So I'm going to go with that one. Okay, so data equals, do we want to include the NAs in there?
I guess we can start out with the NAs in there.
Okay.
It might give us a better model, maybe.
We'll try it. And then formula is clutch. Is it capitalized? Yeah, no, it's lowercase. Size. Maybe we should have cleaned these names up better. Clutch size as a function of mating system. Okay, what did I forget?
From data. Is it the you have to put them in quotations for the names?
No. Since it knows about our data frame, it's going to look for those. As long as they're one word, we can find them. It's really why you don't want spaces in your column names.
Is it the summary that you've...
Yeah, I need to summarize this. So I could either save this as a thing, which I think I'm going to do.
Oh,
Save
right.
that as mod 1 and then say summary mod 1. There we go. Okay. What's our answer?
Missingness. It says a bunch of observations deleted due to missingness. What is
That's
missingness?
Our NAs.
Oh, so our NAs it just got deleted regardless. Didn't matter.
Analysis of variance does not know how to deal with missing values, and so by default it's just going to throw them out, which is actually that's beneficial. We don't have to deal with them ahead of time. All right, so what's our answer?
looks significant to me.
It does to me as well. In
Triple star.
what direction? This is where we can do, since we use ANOVA. Oh, wait. We did forget something.
Would be
Womp womp. And Tukey's not going to work yet. We got to call that a factor.
So we should just change that permanently
What's
for
that?
at least this script. We should just make that as a factor up on the top of our script real quick.
Okay. I think I agree with you there. DF mating system is factor DF mating system. And it won't matter that we have our little factor in here because it's already a factor. It'll be fine. So from now on, we won't have to type factor. So let's run all of this again. Control-Alt-B. Here's our plot. It's resaving our image, and then boom, we get our result. It's still significant for us, and there is our Tukey test. How do I read that? It's kind of a lot. What's the first row telling me?
It's the mating system 2 as a compared to 1.
Mm-hmm.
Is that how you read it?
What's the direction of the difference? Which one's bigger?
Let's see. So 1 would be bigger, right? Because it's a negative value in the difference.
Yeah. Let's plot it. So I can just send that to the generic plot, and it's going to bunk, give it to me. So 2 minus 1, we get that difference. These two weren't significant. They're 95% error bars across the 0 point, and then here's the rest. And so it looks like for almost all comparisons, there's a difference, except for 4 and 3 and 3 and 1. Can't really tell those apart.
Really quick, how would you do a Tukey plot in ggplot?
Oh, look at this. This has all the information we need for that plot.
Okay, you just
It's got our difference. So the difference is the little center bars. Okay.
Mhm.
It's got our lower, upper, which are our 95% confidence intervals. And so it's a pain in the butt, but we can do it. So what we could do is add another package up here. I believe Dalton asked about this one before. No, not per. What was it? The tidy function.
broom.
Broom, thank you. So many packages.
Yep.
And so then we say tidy, and it gives it to us in a data frame.
Oh,
So we
okay.
can just save that as Tukey DF. And so that is what we would send to our ggplot.
Yeah.
And so we would give it the geom error bar, and tell it like the X minimum, X maximum, and then it'll actually make those little bars for us.
Ooh.
Does anyone want to see that? I haven't done that in years. It might be slow.
I kind of do.
Let's do it.
If that's going to help us with the project.
It might. I mean, if you need to do a Tukey plot, I will accept this generic one. This works.
Yeah.
Re-engineer this. Reinvent the wheel though. Names Tukey DF, just so I have a little list of them to look at. Okay. G plot. Tukey DF. My aesthetics. X equals what?
So would that be the differences in mean? So the diff
Estimate.
Okay.
Right here, estimate, because that's our little values, right? Yeah, only that one's negative. So estimate X min equals 91. Does that look reasonable to you? X max equals conf high. Okay. Plus, oh, I forgot the y. What should our y axis be?
That should be term, right? Or no, contrast. Sorry.
Contrast, yeah. Okay. Geom error bar. Horizontal. Let's see if this is not going to work. Hey, it worked. That's great. Okay, and you know what? Let's make it look the same. So we'll do a geom V line. That's a vertical line. And we'll say aesthetic X equals 0. So it'll be at our 0 point, and we'll say line type equals 2. Wait. What? Question mark. Geom V line. I knew this would embarrass me. It wants X intercept, not X. X intercept. There, that's pretty. Plus theme minimal. Plus GD title. Tukey test plot. Cool. Now let's save that. In output. And we'll call it fig2. Tukey test.png. PNG. Okay. However, we did this model, we looked at it here, but we didn't output the results. So let's go ahead and right here do sync output ANOVA table.txt and then a sync no. Okay,
Just
now we're happy.
With 2, right?
What's that?
For the second sync, just sync should work, right? Like without anything in it. Like It's equivalent, yeah, or no?
I've only seen it written like this. I've never tried it by itself. I
Okay.
think that by itself, it's looking for the name of a file. So I think best practice, say sync null, that's closing the connection to that file.
All right. Sounds good.
So let's look in here. Now we've got our ANOVA table. Neat. Okay. We've got our table 1 and 2 figures. Okay. Now there's another little trick. That I'm going to show you because it comes in real handy when we make our report. RDS versions. Okay, so we're going to save RDS. We're going to tell it the object to save and then the name of the file to save it to. So let's say summary mod 1. We want to save that as a, not TISSY, tidy. We want to save that as a little like, oh, it doesn't work. I forgot. Why doesn't it work? We can translate this error message.
Can you not save summaries, or you can't save a model, or?
Tidy doesn't want the summary, it wants the model. It'll do the summary for you. So there's our, so we say mod 1 tidy. So I'm going to save that as output, and I'm going to say ANOVA.rds. Okay, so now that RDS file, it's a compressed, like basically a zipped binary document, not document, file. It can be read into R at any point with read RDS. Okay, if I read RDS and then give it this file name right here, I'll just copy that so I don't have to type. It'll show that to me, or I could save it as, I'll call it W, why not? So now I've got a thing up here called W, and it's actually an R object. So it knows that it's a data frame. It knows that this is a double, that's a double. You don't have to parse anything. There's no reading in CSVs. And it takes up way less space, which isn't important for this. But if you had a really giant file, like say, all the New York Times data on COVID transmission and deaths, right? That could be a big CSV file. So if you spend a lot of time getting that cleaned and tidy and ready to go in your tidy script, you may want to save it as an RDS instead of a new CSV. Because that way it comes in exactly the way you had it, the way you wanted it, and you can start by reading in that RDS. Okay, so I'm just going to comment that out. I'm going to save this as O2 bird data analyses. Okay, so we've loaded our data, cleaned it and tidied it, visualized it, modeled it, and now it's time to do what?
Analyze.
Nope.
No,
Would it be to test our models?
Let's pretend we did all that. I don't want to spend too much time doing this.
Okay.
Report, communicate.
Oh, okay.
And so that's where we go, file, new file, whoops.
Markdown.
R markdown. Okay, I want it to print to an HTML. I'm going to say final project. Okay. Final project, blah, blah, blah. I'm going to delete all this garbage that we don't need. And I'm going to say, let's do some R code here. I'm going to save this right now, and I'm not going to put it in R. I'm going to stick it right here in my main folder, and I'm just going to call it report. Okay. Now, this is important. I'm just going to close RStudio and then open it back up. Why am I doing this?
To illustrate the importance of a project, or?
Well, sure, but there's a more important reason. I had a whole bunch of stuff up here in my global environment from those other scripts that I was already typing. I do not want to start writing a report and count on that stuff being there over here, right? This is what got you, some of you, on your last exam. Pretty sure. I think I made comments for all of you that had this problem, but you were calling functions on an object that wasn't actually produced by your script, probably because another script had made that and it was still in there, and so it didn't give you an error. The collaborator downloaded your project, your script didn't make that file. So restarting RStudio is like the clean slate. It makes sure that we're not encountering any errors from leftover objects. So now I'm gonna. What's that?
Can you just click the broom?
Yeah. Do you want to count on that?
But just a quick question on like the difference between clearing your environment and clearing the console. What would clearing the console do for you?
Okay. There are hidden objects also in your environment. I didn't want to get into this, but they're there. If you click the broom to get rid of all that stuff, it doesn't necessarily delete all the hidden objects, and it only deletes them from that particular environment. Look at all these other environments we've got. These are all functions that are currently loaded by default. Other stuff you've done in R may have loaded things into those, and you don't want to count on those being carried over. So really the best practice, and I've seen an entire talk at an RStudio conference that was just about why you should, every half hour, save your work, close RStudio, open it back up. It really helps find those errors. So I'm going to open my report. And the first thing I'm going to do here is say previous script cleaned the data. Maybe I'll give that, not make it too big. Can be found at R, and then what was the name of that? Clean bird data R01. Bird data R. Okay, so now what do I want to say about my report? Or in my report? If I knit it now, just let's get a look at what we're working with. Okay, great. It's ugly, it's boring. What should go in here? Maybe those figures? Right, if I open these up in our analysis, we made some figures. We saved them as files. We could just import those files directly. Or, and this is going to be real fun here, I'm going to say P2. And this one, we called it P1 equals that, and then P1. Can anyone guess what I'm about to do?
Patchwork?
I'm gonna say, oh, I could do patchwork. I could do that within my report, though. What I really want to do is not just save this as a PNG. That can be handy, especially if you're working in like Microsoft Word or something. Or if you need those files separate. But maybe I want to say fig1.rds right there. And then here, save this one as fig2.rds. So now I've got them as R objects and just a nice file. I'm going to just go ahead and run this whole analysis again. Ah, error. File must be a non-empty string. I forgot to tell it what to save as an RDS file for both of these. So I'm going to go all the way back down again. Control-Alt-B, run everything. Now we're good. If I look in there, I've got my Fig1 as a nice little picture, so I can just Firefox that, and boom, we can look at it. But I've also got RDS. If I were to look inside this file, it's ugly. That's okay, because R knows how to interpret it. So save that. Okay. I'm going to close everything down again, open it back up, go back into my project, the shortcut button, make this a bit bigger to see, and then I'm going to open up my report markdown file. Did I double click? Yeah, okay, just taking its time. So now if I import that old plot that I made with the other script, I can just do read RDS. Oh wait, let's add some libraries so I can actually work with this. Okay. Read RDS, and that was found in output fig1.rds. Let's compile this whole thing, Control-Shift-K. And there it is. Okay, so we went ahead and left this in. We could have told it what to get rid of this whole warning thing. It's kind of ugly.
Make something
What's the
false.
magic word for that? What's that?
You had to make something false, right? Or
Warning
yeah.
equals false. Yeah,
Oh.
warning equals false and message equals false can get rid of all that. But there's our plot, and I did something kind of silly that you haven't seen before. Since I read it in as an RDS, I could just have said P1 and it would show up, or I could do this ggplotly, which lets me click on things. It's an interactive. I can't hear your gasps of surprise at home.
So,
There you go. All right. It also lets you like zoom in on different regions if you want. So this is kind of a fancy thing. If you want your plots to be interactive, it's really that simple. The plotly package, and then you can just say ggplotly. Boom, there it is. So there's our report. Everything's saved, and whoa, that's ugly. Well, clear. Okay. I look around here. This is my final project in all of its glory. I've got my HTML. It can be opened on any browser. My report, Markdown, and my little R files are segregated all by themselves, not cluttering up my directory structure. Same with the output, same with the data. So we've got our data, the raw data, and then the cleaned version. This is awesome because if this raw data changes, like we add new rows to it or something, all we got to do is rerun our R scripts, recompile the report. Everything's corrected. all this output will also be changed if we had new data. The ANOVA table, here it is. So maybe we just add that to our report next. Say warning equals false. Warning equals false. And let's see, ANOVA.RDS. Let's do that. Read RDS. Output ANOVA.RDS, and we'll save that as ANOV. If I say echo equals false, what's that going to do?
Also doesn't.
It'll hide
show
the
something.
code, right?
Yeah, that's going to hide the code for me. So I'll need to add a little explainer here, like, here's figure 1. Yay. Okay. Here's our ANOVA model output. All right, but that's not going to actually give me my ANOVA model output. Why not? We've got our figure 1 here, and then that's the end. It just said, here's our ANOVA model output, and didn't show it. Help me.
Do you need something to read a text file?
If I just want to display the contents here,
Oh, cat, huh?
I could do cat, but it's a data frame right now.
Hmm.
Can you display a data frame in your Markdown?
You can if you use this fun little package here, Cable Extra. I can say cable ANOV. Let's see what it did. Yeah, it's pretty ugly, but it made us a little table out of it. So that's exciting. There's a lot you can do with that cable. Tell it the format, how wide to make things, row names, column names, align equals center, left or right. You can kind of see what it'll look like in there. So that's just for making tables out of data frames. So we could do that, or we could have just said summary ANOV. Control Alt K to knit. So let's see the difference here. Can you hear my dog snoring? He's going crazy. That gave us a bunch of junk. I prefer the cable. All right. So there, I get that this is an ugly report. I want yours to be nicer than this. Obviously, more explanation and everything. But this is to illustrate how your project design can actually help you keep things nice and tidy, right? Keep your output somewhere. Sometimes if I have a lot of statistical tables and a lot of figures, I'll even add subdirectories in here, one for like text files and statistical output, one for RDS stuff, and one for just nice figures. So you can customize this however you want. Okay. But this project, git status, git add everything, git commit version 1.0. Oh, I forgot. Message version 1.0. Okay, so now it's a Git repository. I could push that to an online version, send it there. Anyone can download that. They've got my data. They've got all the analyses. They've got the code to make those files, and it's a nice self-contained little package. Since we did the shutdown and restart thing, so many times. We also know that it's not depending on anything weird left over in our environment. Questions about organizing for your final project? Yeah.
Kind of. I'm just trying to think of when I finally get to like the marks down part of what exactly I'm going to include. Is it just going to be kind of similar to the other assignment that we did?
Yeah, exactly.
Where I just, I explain, hey, I did this. Here's a graph about that. This is what we can tell from it, and just do that.
Yeah, ideal.
Okay.
But in that one, it was all included, right? All your code was in there, including all the cleaning and everything like that. For your final project, I don't need to see all the behind the scenes stuff. Think of this as a report that you would give to somebody that doesn't know any coding, right? This is for a collaborator or for, a report, just like a science report in the lab or whatever, right? It's a Word document essentially that we're making. It just happens to be a nice responsive HTML that lets us do fun things like include interactive plots, for example. But yeah, here's what my data set is. Here's some visualizations of it. Here's what it's about. Here are the hypotheses I was testing. I tried a couple different models. This one works the best, so I'm running with that. Here's the output. Here's how to interpret it. Here's the conclusions. And you're good to go.
So how are you going to grade it then, not knowing, like, are you just going to assume we put in a bunch of effort into finding and cleaning and everything, since we're only giving
I'll
it?
see it. I'm not just going to look at your HTML. I'm looking at your whole project, and I'm going to look for where your scripts are, and I'm going to see what happened. Yeah.
All right. So that's why. So we're presenting our entire, I guess, like project folder.
I am taking that whole folder and picking it apart.
Okay.
The thing I'm looking at though is the HTML. That's your polished report. I'm going to start there, and if I say, man, I bet this was a really dirty data set, how'd they clean it? I'm going to go look for a script that talks about cleaning, for example. Yeah. I'm not going to have to assume that a lot of hard work went into it. I know that a lot of hard work went into it. All of you are using real data sets. They're going to be ugly. They're going to require cleaning. If you do it this way with a separate cleaning script, it does make things a lot easier, because once you run that and you get your like RDS file at the end here, you don't have to do that cleaning again. You can reopen your project and start from a nice clean data set. So that's why I like to kind of split this up. In other projects, so here's one. You can see I've got data, other, because I am lazy with naming things, output, R, taxonomy, and then here's my report. It's all there, and I've got other files, a nice README, all that kind of stuff, explaining what's in here. But if I go to my R, it starts getting ugly, right? So I ran some analyses, and then the people wanted other stuff done a different way, and so I've got O1B, O2B, O3B. So it starts getting ugly, but as long as you have a good naming convention, they do stay in order. Okay. But this is a lot of lines of code, all told, and so having it split up like this prevents me from having to rerun long, complicated algorithms. For example, cat. This is the entirety of this particular script. It took 2.5 days on a supercomputer to run. I don't want to have to do that every time I restart this project, or I'll die working on it. Okay, so that's done. It's made some files that I can read with the next script and so forth. So break your project up if it's really big. For yours, you may need 3 or 4 different scripts. Once they start getting really long, save your progress with that RDS, move to a new script. So here, all my beta diversity analyses are contained in this one. And here's differential taxon abundance, and then another comparison. Okay. That makes sense? Or am I making things worse?
Makes sense.
Okay. Well, who has data problems? At least one of you so far. If you don't have data problems, you should.
Right. I'm going to try and struggle through it for a while. And once I hit a roadblock with like YouTube videos and stuff, I'll message you. Maybe we can do some office hours to look at it.
Okay, don't shy away from bringing it to the class either. So on Wednesday, the entire class period will be dedicated to your data problems. If it's something that you're encountering, odds are pretty good that somebody else is encountering that as well. And so we're going to all learn from each other's errors.
Okay.
So yeah, don't be afraid. Don't be embarrassed. It's fine. We all suck at this, just to varying degrees.
I have a question.
Great.
So in mine, there's dates, but when I look at their class, they don't actually appear to be in date form yet necessarily. They're like something else. But I look at all the date stuff I can turn it into, and there's a lot of them, and I don't know which to do. Like I think even for Zoo, there were like 3 types of dates I could turn it into or something silly like that.
All right. I'm going to go into data course Zon. Do you have a file that you could upload real quick?
Yeah, I can put the CSV on Teams.
Yeah, throw it on Teams, and I'll get set up, and we'll just look at the actual file, so we know what we're dealing with.
All right, that'll just take me a few moments.
Okay. So we're always going to want tidyverse. We may not need tidy. We'll see. So you've been using Zoo, right?
Yeah, I've been looking at Zoo.
Okay. So we're going to want to convert things into basically a as date using the Zoo version of as date. So if I do question mark as date, it's like, hey, do you want the base one that came with R, or do you want this special one, an index class for monthly data? I don't know that we're going to want this. We can probably use as date base. So I'm going to copy that, close RStudio again, reopen it. This happens like a dozen times a day in my house. Let's hold off on Zoo for right now. Let me know when your file is up on Teams also.
All right, I put it into copy and paste code.
Cool. Come on now. I'm gonna find it, I swear. Okay, there it is. It is presumably downloading now.
Yeah, it's not small.
Right.
I had to download like the whole thing though, like a whole bunch of other stuff, because the code button you click only gives you like one URL, and if you click in further, it gives you nothing. So I had to actually download a lot more in order to get to it. Couldn't find a way around that.
That's fine.
Is that normal?
Yeah. Oh, very, very normal. Okay, so that's a 29 megabyte file. Yeehaw, let's get it in here. Read CSV. That's in my downloads, US counties.csv. Okay, that's fine. There's only 732,000 observations. Let's see what we got here. Date. It came in as a factor. Yeah, we want to convert that to date. So we're going to do df date. We're going to send that to as date. And let's just see what we get. Oh, could not find function. Squiggle, squiggle, squiggle. Let's see here. Well, it's a date already. Your problem is solved.
So like I'd use a month one when it's actually in months, and this is just good as date.
So here's what I did. I used read_CSV instead of read.csv. This is the version that came with tidyverse. And it automatically detected that that's a date and saved it as a date. So let's see here. So df date class. There it is. It's a date. So I think we accidentally solved your problem instantly.
Didn't even have to do anything.
Yep.
Okay.
So use tidyverse and use the read_CSV, and you're good to go. Now with that, we can use the zoo package. Okay. This will change that date into a time series. So let's see what else. If we wanted like either cases or death, right? So we could do zoo I think it's just zoo. Yeah. So the zoo function in the zoo package. Oops. It's taking its sweet time. But that's gonna give you a brand new object up here. And it's called a zoo. You heard the word zoo enough now? So we've got your data frame. We use the zoo package, the zoo function, to create a zoo object. It's got its own object type because it treats this as a time series now, and so we can use like predictive modeling, ARIMA models, or that real cool one that I showed you earlier, just out from Facebook, Prophet, which allows you to predict the future based on time series, but it really needs that daily time series value. So let's see. Plot DFZ should have a built-in plot function. We can just take a look at this and see what we're working with. Need finite ylem values. Okay. So I don't know what I'm doing. Hey, stop. So we can tell it what to order by. In this case, it would be date. Frequency, it'll check and do that automatically. Yeah, that's good. It's just not wanting to plot it outright, but that's okay. If we do ggplot on our original DF, aesthetic x equals date, y equals, what was the, say, deaths. Oops. And then let's do color equals state, just so we get a really ugly plot. And then groups, group equals state as well, geom line. Let's see what we get. This is going to be hideous. It's going to need some work. That's a lot of observations, and it's going to have 50 colored lines bouncing all over the place. Whoo! And the human eye cannot tell apart that many colors, so this is probably not a great way of looking at it, but there you have it.
But you just gotta wear polarized sunglasses when you're looking at this.
It's pretty bad. You may have to make groups of states, like make another column that says like region, and you could do like Northeast, Midwest, Northwest, Intermountain. You could do that and then facet based on that, so there's fewer lines per facet. That might help. But the data's there. We can definitely build models. We can see if state matters over time. What's interesting about this is that since it's a time series, instead of just looking at total death numbers, we could actually use the trajectory, and that's where Zoo is coming in. It's going to let you model based on the different trajectories for these different states. Okay, so that's like an ARIMA model, or using the Prophet. Prophet's nice because it's easy, real easy to use, as long as you have daily data, which you do. So did that help?
Yeah, it does.
Okay. Anyone else? We got a few minutes remaining. I'm going to take your silence as a no.
I have a comment, I guess.
Great.
Dr. Zahn, so you want the R file to have all the comments and all the analysis, right? And then you want the R markdown to have all the images and just the presentation of the data, right?
Yeah.
Okay, cool.
Now that's a bit different than your assignment 9, where all of your code was also in there. If you want to do it that way, that's fine. I've found that it gets pretty messy pretty fast.
Yeah.
Yeah, it gets real ugly. And so what I was trying to show you was another way where your actual code can do all its stuff in the background. You run it, and then if you've saved all your images and RDS or however you want to do it in output, your markdown file can just read the polished stuff right in and present your results. Yeah.
Okay, and how would we make a reference to the code? Like, let's say I just want at the end say, oh, here's the code if you want to look at it, and I don't know. I mean.
Oh, yeah. Since you're giving your collaborator all this stuff, you can just say the name of the file, right? So you could say, for the cleaning code, see this file.
Okay.
For the analysis, that one. That's fine with me.
Or would a link to like the GitHub repository work? Like,
Yeah, it sure would.
okay.
So you could put a link in there. The deal when you do that, though, there's a bit of a trick. GitHub. I'm gonna let my dog out. This is being ridiculous. Skedaddle. Okay. So let's say exam 3, and I wanted to link to this readme.txt. You don't want to send the link to this address. You actually want to click on the file and then click on raw. That changes the URL up here. You see it starts with raw.github user content.
Oh,
But that sends you right to the actual contents of the file, none of the other junk around GitHub. So if you put your link to that, it's more of a direct, here's what's in the file.
okay. Cool. Yeah. Thanks.
And with this in mind, any questions yet on exam 3?
Ooh.
Has anyone started?
No one's a do.
Oh.
I loaded the data, but that's as far as I got.
Okay.
Yeah.
You're gonna love cleaning these. I think the hard one to clean is probably the 1995 faculty salaries.
Yep.
Yeah. But go back to our bird cleaning and see how we broke that down.
Right. I was gonna ask about that. Like, I was trying to look for the lesson. I don't know if by chance you know what week it was. Like, I know it wasn't too long ago, but
3 lessons ago.
Okay.
Yeah.
So, thank you.
Because that it does need to be broken down into a few different things to get it clean. It's pretty messy. Git repositories. File 3100 exams. CD exam 3. Okay. Faculty salaries 1995. Let's just look at the top of it. So we've got average for all these things. We've got salary. We've got full professor, associate professor, and assistant professor. Okay. So what they've done is actually crammed a bunch of variables into this name. So we know that this particular column means full professor, and it's salary, not compensation. And so you're gonna have to split these up before you do your pivot longer, just like we did in the bird. So go back to that lesson and that'll help.
That's due at the end of the Thanksgiving break, right?
Mm-hmm. Once you get it cleaned, the test is pretty easy. And same thing for the juniper oils. That one's a bit dirty also. It's not as bad. And it looks worse, but it's not actually as bad. It's got all these different compounds that were measured with a mass spec and then their concentrations. So you're going to have to basically take all these compounds and stack them up with pivot longer. But as you may have noticed, I gave you the list so you don't have to type them all out. You can use that vector. All right, we are out of time. Bring me more problems on Wednesday.
They have to be exclusive to coding?
Yes.
Can we also bother you in between?
I don't get paid enough to deal with any of your other problems.
Okay.
No. They don't have to be related to your final project. If you have stats homework or something you're struggling with or just something you're trying to clean, that's fine because we're going to learn from that also. But You really do need to be digging into your final projects already. You're going to be out of time by the end of the semester.
Yeah, I was referring to the final project, of course.
Yeah. And I promise you will encounter errors. It's just going to happen, and that's what I'm here for. So if YouTube's not helping you, that's fine. Bring it to class, and we'll work through it together. And that's all I got. I'll see you Wednesday.
Thanks.
Yep. And it's not letting me click on anything. I'm stuck in this meeting forever.